Now let us understand the mechanism of adsorption. See, we need to see what exactly happens when a substance is actually attracted on a surface of the other. See, we know every substance which have a well-defined surface like solids, like if suppose this is what is the solid we are having, definitely the molecules or the particles which are present at the surface of these substances or which are this surface will be having different environment than the ones which are present in the bulk. This is what we have, the bulk, and this is the surface. Now what happens in the bulk is that any particle which is there, whatever the forces of attraction it experiences from the surrounding other particles, they all get cancelled each other or balanced each other. But the particle which is there here experiences unequal forces. So usually what we find is they always have tendencies of have attractive forces. Or what we can put in the other words is, we know that if every substance will be made up of ultimately atoms, and these atoms, if even they are in a polar molecular system, definitely they will be having certain dispersion forces which we call instantaneous dipoles, the basic of those. So they always have instantaneous dipoles. These moving electrons in these atoms are always having this kind of a thing. So whenever other substances, if like I am telling you the example of NO2 gas, like if this molecule comes in contact or very close to this surface, due to the polarity in this molecule, it very easily gets attracted to this surface because they develop dipole-dipole interactions. Now as a result, it gets stick to this. Now due to this, what happens is the forces are becoming what lesser, energy is released. So, and the forces of attraction are forming energy is released in this. So always remember, this adsorption phenomena is accompanied by release in energy. Now do you mean do you understand what exactly the release of energy means? It means that the enthalpy of adsorption, we can write here, will be negative always because energy is released in this process. And if we are considering gases, like I have given you the example of NO2, definitely the entropy of this adsorption is negative because gases are what? Forming forces of attraction with the surface. So the randomness these gases were having is lost or is decreasing. So entropy is also negative, enthalpy is also negative. But what is most important is, we know these processes are spontaneous. They take place on their own. So that means what? Delta G of adsorption is always negative. Why? Because the processes are spontaneous, and we know the formula, delta G is equal to delta H minus T delta S. So basic is here, and that is why this adsorption phenomena is a temperature based phenomena, because this T has to be what? It has to be under certain limits, otherwise this negative delta S has already will make this term positive and the sum of the two will become positive. So that is why adsorption at higher temperature is not favorable. With the increase in the temperature, it decreases. So it takes place at a lower temperature or at room temperature conditions. So this is what you have to understand, the mechanism. It is the forces of attraction which develops between adsorbate and adsorbent, and therefore the enthalpy of adsorption is always negative. Entropy of adsorption is also negative, because if you are considering the adsorption of gases on the solids, so and overall, since all of these adsorption processes are spontaneous, delta G is negative. So this is what is the relationship we have. Now on the basis of this, therefore, on basis of what? We need to understand the forces which develops between the adsorbate and the adsorbent. Adsorption is classified into two major categories. Now let us understand those two categories under the topic types of adsorption.